Okay, so hello and assalamu alaikum to you all. My name is Muhammad Ishaq Ali. I study at Rehan School Online Academy in batch number 7. So today we are back with another session with Maya on the topic Earth. So today we are going to talk with her on the topic Earth. So first of all, hello Maya, how are you?
Hi, Mohammed. I'm doing well, thank you. And assalamu alaikum to you too. It's good to be talking with you again. I'm excited to discuss the topic of Earth with you today. That's a pretty huge subject to cover. What specifically about Earth are you most interested in learning about today?
Okay, so like today we are going to talk um,
Yep, definitely. We're here to talk all about Earth for the next 30 minutes.
Today we are going to talk here on the earth like natural resources and from where the earth came, like that some questions. So my first question with you is what is the shape of the earth?
That's a great place to start. The shape of the Earth is actually pretty interesting. It's not perfectly round like a ball, but it's not completely flat either. It's what scientists call an oblate spheroid. Imagine you're spinning pizza dough. As it spins, it gets wider around the middle, right? That's kind of what happened with Earth. When our planet was forming billions of years ago, it was spinning super fast, and that centrifugal force made it bulge a little at the equator. This means Earth is wider across the middle than it is from pole to pole. Also, the Earth isn't perfectly smooth. Mountains, valleys, and the ocean floor all contribute to its varied shape. So, while we often say Earth is a sphere, it's a bit more complex than that, like a slightly squashed sphere with bumps.
Okay, so Maya, my next question is, please can you explain me that how the earth has been invented and from where earth has came?
That's a big question. And the story is a fascinating one. The Earth formed about 4.54 billion years ago. That's incredibly long ago. It started with a massive cloud of gas and dust swirling around the newborn sun. This cloud, left over from when the sun itself formed, was mostly hydrogen and helium, but it also contained heavier elements forged inside ancient stars. Gravity started pulling these particles together, and over millions of years, these tiny dust grains slowly stuck together, forming bigger and bigger clumps. And these clumps eventually became planetesimals, essentially baby planets. As they grew, their gravity pulled in more and more material. The Earth really started taking shape when it collided with a Mars sized object called Theia. This collision was absolutely massive. It basically smashed into the early Earth. The impact ejected so much debris into space that it eventually formed our moon. Over millions of years, Earth gradually cooled down. The heavier elements like iron and nickel sunk to the core, creating the Earth's metallic core, mantle, and crust. So, our planet's creation story is really one of gravity, collisions, and billions of years of cooling and settling.
Okay, Maya, so please can you tell me from where the water like how the life has started on earth?
Okay, so that's two questions bundled together: water and the start of life. Let's start with water. It's actually a bit of a mystery exactly how water ended up on Earth. There are a couple of main theories. One idea is that water was already here when Earth formed. Water molecules were actually built into the dust and rock that made up the early planet, brought by asteroids or comets from the outer solar system. Alternatively, water could have come from volcanic eruptions. As Earth's volcanoes erupted, steam came out and formed clouds, which turned into rain, which began to fill the oceans. Now, as for the start of life, scientists believe it happened around 3.7 billion years ago. The Earth's early atmosphere was very different. Lots of gases like ammonia and methane, but very little oxygen. Lightning or volcanic eruptions may have provided the energy for simple chemicals in the ocean to form amino acids, which are basically the building blocks of proteins. These amino acids eventually formed into more complex molecules and then eventually very simple single celled organisms. These first life forms likely thrived near underwater volcanic vents because the gases released provided the energy they needed. It's still kind of mysterious how it all happened exactly, but these early life forms eventually began producing oxygen, which dramatically changed the Earth's atmosphere and led to the kinds of life we see today.
Okay, Maya. So my next question is, um, what stars give light on heat to Earth?
The star that gives Earth light and heat is our sun. It's a really important relationship. Basically, everything on Earth wouldn't be able to exist without it. The sun generates a lot of energy through something called nuclear fusion. That's when atoms of hydrogen smash together under tremendous pressure and heat, releasing energy in the form of light and heat. This light and heat travels across about 93 million miles of space and reaches Earth in just over 8 minutes. Earth's position is absolutely key. We're in what's called the habitable zone or the Goldilocks zone. This means we're not too hot like Venus and we're not too cold like Mars. We're just the right distance for liquid water to exist, which is crucial for life as we know it. The sun also influences Earth's seasons because Earth is tilted on its axis. Different parts of the planet get more direct sunlight at different times of the year, causing summer and winter. So, yeah, the sun is pretty much essential.
Okay, Maya. So my next question is, can plants grow on Earth?
Absolutely. Plants are a fundamental part of life on Earth, and they thrive here. Although not everywhere on Earth is equally suited for plant growth, of course. Plants grow from tiny seeds or sometimes from cuttings or roots. When plants grow, they need several things: sunlight for energy, water to help carry nutrients, nutrients from the soil, and air for carbon dioxide. They use sunlight, water, and carbon dioxide during a process called photosynthesis to create their own food. As they create food through photosynthesis, plants release oxygen into the air we breathe, and they form the base of the food chain. There's a huge variety of plants on Earth, from giant trees and rainforests, to tiny plants in deserts, to floating algae in oceans. The amount and types of plants depend on climate, soil type, and sunlight. You find forests where it's wet and warm, grasslands in temperate areas, and cacti in the desert, for instance. So, yeah, plants not only can grow here, but they're actually what make life possible for so many other organisms on Earth.
Okay, so please can you explain, Maya, what are the layers of Earth like troposphere, etc.? Detailedly, can you please explain?
Oh, yeah, the Earth has layers like an onion. You mentioned troposphere, which is part of the atmosphere, not actually part of the Earth's layers, but we can talk about both. I'll explain both what you meant: the layers of the Earth itself and then the layers of the atmosphere above it. Let's start with Earth's layers first. You've got the inner core, outer core, mantle, and crust. At the very center is the inner core. It's solid iron and nickel because the pressure is incredibly high and it's scorching hot at around 9,000 degrees Fahrenheit. Surrounding that is the outer core, which is still iron and nickel, but in liquid form. This liquid outer core generates Earth's magnetic field, which protects us from harmful radiation from the sun. Next up is the mantle, the thickest layer, made up of hot, dense rock that flows very slowly like caramel. Finally, the outermost layer is the crust. It's cool and rocky, and where we live, made up of continents and the ocean floor. Now, for the atmosphere, this has multiple layers too. The troposphere is the closest layer to Earth's surface and where all the weather happens. The stratosphere is above that, and it has the ozone layer, which protects us from the sun's UV rays. Above the stratosphere is the mesosphere, where meteors burn up. Then the thermosphere, which gets super hot. and then the exosphere, where the atmosphere gradually fades into space. So many layers protect our planet.
Okay, Maya. So my next question is, how many continents are there on Earth?
Okay, so there are officially 7 continents recognized today. They are Asia, Africa, North America, South America, Europe, Australia, and Antarctica. Asia is the largest continent, covering about 30% of Earth's total land area, and Antarctica is the coldest, driest, and windiest continent. Historically, some people have grouped continents differently. For example, Europe and Asia are sometimes combined into Eurasia. What's interesting is that continents aren't actually fixed. They've shifted over millions of years due to plate tectonics. The land masses have broken apart and collided with each other repeatedly. Continents like Africa, South America, and India once formed a supercontinent called Pangaea over 300 million years ago. Scientists have evidence for that shift in the landmass. So while 7 is the number we recognize today, Earth's geography has been changing for a long, long time.
Okay, Maya. So my next question is, what do we call the very large piece of land on Earth?
We call the very large piece of land on Earth a continent. That's what we were just talking about. These 7 large land masses: Asia, Africa, North America, South America, Europe, Australia, and Antarctica. Essentially, continents are huge continuous stretches of land. They're much larger than islands. Continents typically have diverse landscapes with different climates, ecosystems, and cultures. Continent is the general term to describe these massive land areas. Sometimes land mass is used too, but continent is the proper scientific term.
Okay, Maya. So can you please explain me detailedly like how these continents have formed?
Absolutely. The story of how continents formed is a long one, going back billions of years, and involves something called plate tectonics. So, early Earth was very different than today: molten rock and a fairly thin crust. Over time, as the Earth cooled, this crust began to solidify into huge plates like a cracked eggshell. These plates aren't fixed in place, though. They're constantly moving very slowly, floating on this layer below called the mantle. Now, about 300 million years ago, these plates crashed together, forming a single supercontinent called Pangaea. Pangaea started to break apart around 200 million years ago, and slowly, over millions of years, these pieces drifted apart as the plates continued to move. Why did they move? Well, because of convection currents within the Earth's mantle. The mantle is hot and dense stuff, so it rises, cools, sinks, repeats, essentially creating a slow churning movement. These currents act like conveyor belts underneath the plates, pushing and pulling them around. We still see this happening today. The continents are still moving. Africa is splitting along the East African Rift Valley, for example. So it's been billions of years of plates grinding, colliding, and separating that's created the continents we see today.
Okay, Maya. So can you please explain me what are the volcanoes?
Volcanoes are pretty amazing geological features and sometimes very dangerous. A volcano is basically a vent or opening in the Earth's crust through which molten rock, ash, and gases erupt. It's formed when magma, which is molten rock beneath the Earth's surface, rises to the surface. How does that happen? Well, like we talked about before with plate tectonics, the plates are constantly shifting. In some places, one plate slides under another in a process called subduction, where the denser plate sinks under the less dense plate. As that plate sinks, it melts into magma, or magma forms at places where the plates are separating or at hot spots inside the earth. Once the magma rises to the surface and erupts, it becomes lava. When lava cools and hardens, it builds up layers around the vent, creating the cone shaped mountains we typically think of as volcanoes. Volcanoes can be active, dormant, or extinct. Active volcanoes erupt relatively frequently. Dormant volcanoes haven't erupted in a while, but could erupt again. Extinct volcanoes probably won't erupt again. Volcanic eruptions can be very explosive, sending ash, gas, and lava high into the air and across vast distances.
Okay, Maya, so can you please explain me, um, like, how the humans have started living on Earth?
Oh, you're looking for the story of human evolution. It's an amazing journey that spans millions of years. Our earliest ancestors weren't humans at all. They were primates living in Africa about 6 to 7 million years ago. These early primates gradually evolved through natural selection. Over time, they developed bigger brains, started walking upright, and began using tools. The earliest member of our direct family, known as Homo, emerged around 2.8 million years ago in Africa. Homo habilis was one of the first, and it's called the handyman because it used basic stone tools. Around 1.9 million years ago, Homo erectus emerged and started migrating out of Africa and spread through Asia. This group was even more advanced and used fire. Then, our own species, Homo sapiens, emerged about 300,000 years ago in Africa. We spread across the globe, adapting to different environments and developing agriculture around 10,000 years ago. This allowed humans to settle in one place and create civilizations, which eventually evolved into the societies we have today. It was a long process of adaptation, tool use, social development, and migration that allowed humans to thrive across the earth.
Okay, Maya, so my next question is, is Earth hot everywhere or different in different places, like temperature?
Definitely different temperatures. Earth is not hot everywhere. It varies quite a lot depending on location. Some places are freezing cold, like Antarctica and the Arctic, while others are scorching hot, like deserts. The main reason for this difference is Earth's axial tilt. The Earth's axis is tilted at an angle of about 23.5 degrees, which creates seasons. When a region is tilted towards the sun, it receives more direct sunlight and experiences summer. When it's tilted away, it experiences winter. Plus, there's latitude. Areas near the equator get more direct sunlight year round, making them warmer, while areas near the poles get less and are much colder. Another thing affecting temperature is elevation. Mountains tend to be colder than valleys because the temperature drops as you go higher in elevation. And the proximity to water matters too. Oceans and lakes help regulate temperature. So coastal areas have milder temperatures than inland areas. So all these factors combine to create the different climates we see across Earth.
Okay, so Maya, can you please explain me what do we call the coldest place on the earth?
The coldest place on Earth is Antarctica. More specifically, the highest recorded natural temperature on Earth, minus 89.2 degrees Celsius, was recorded at the Vostok Station in Antarctica on July 21st, 1983. The entire continent is incredibly cold, it's completely covered in ice, and experiences extremely harsh conditions year round. Antarctica has high elevation and receives very little sunlight during the winter months, with some areas experiencing complete darkness for extended periods. The dryness also adds to the cold pier. The cold air can't hold as much moisture, making it feel even colder. Other incredibly cold places include parts of Greenland and Siberia, but Antarctica takes the prize for being the coldest place on Earth.
Okay, Maya, so my next question is, what do we call the very dry place on earth? Explain it in detail.
The driest place on Earth is generally considered to be the Atacama Desert in Chile. It receives less than 15 millimeters of rain per year. Some parts haven't had significant rainfall in centuries. What makes it so dry? There are a few key factors. First, its position between the Pacific Ocean and the Andes Mountains. The Andes create a rain shadow effect. When moist air moves east from the ocean, it rises over the mountains, cools, and loses its moisture on the windward side, leaving very little to fall on the leeward side. This creates a very dry area on the other side of the Andes, where the Atacama is located. The cold Humboldt Current flowing offshore also contributes. Cold currents lead to cool, stable air that suppresses rainfall. The Atacama is so dry, it's often compared to the surface of Mars. The landscape there is incredible. It looks like a different planet with salt flats, sand dunes, and rocky terrain. Very few plants and animals can survive there, but specialized species adapted to those extreme conditions have evolved in it. Some areas of the Atacama are so dry that they're used by NASA to test instruments for Mars missions.
Again, Maya, so my next question is, do we breathe air or water on Earth?
Oh, we breathe air on Earth. Humans and most other animals need air, specifically oxygen within the air, to survive. Fish and other aquatic animals can extract oxygen from water using gills. Air is a mixture of gases, mostly nitrogen, but also crucial oxygen for breathing. When you inhale, you take in air. Your lungs pull out the oxygen that your body uses to make energy. Then, when you exhale, you breathe out carbon dioxide, which is actually a waste product from that same energy making process. Water is essential for life, but we can't extract the oxygen we need to survive from it. Like fish can with gills, we need air. Well, we need water to live, we breathe air to live. It's different ways of being alive.
Okay, Maya, so my next question is Earth the only planet known to have life?
That's a really big question that scientists are working to answer. As of right now, Earth is the only planet known to have life confirmed, but that doesn't mean it's the only one out there. Scientists believe there's a possibility of life on other planets and moons in our solar system, for instance. There's evidence of underground liquid water on Mars and beneath the icy crusts of moons like Europa and Enceladus. The main thing that would make a place habitable is the availability of liquid water, the right temperature, and a source of energy. Outside our solar system, scientists have discovered thousands of exoplanets, planets orbiting other stars. Some of those exoplanets are in the habitable zone, meaning the temperature could potentially allow liquid water to exist. So while we haven't found definitive proof of life elsewhere yet, the search is definitely on.
Okay, so thank you, Maya, for giving us your precious time. So we meet another AI session with Maya. So Allah Hafiz. Bye bye, Maya.
You're very welcome. I enjoyed talking about Earth with you today. I look forward to having another session with you soon. Ma'a as salama, Muhammad.
Bye bye.
Bye.